Hey guys, Matt Hoots here with Rate of Green, and I'm going to talk to you about HVAC systems, more importantly, dehumidification. So I saw this crazy article, and I'm in Atlanta right now. I call it Hot Atlanta. I'm actually sweating. It's 90 something degrees outside. I do have a window crack. That's the only ventilation I have in this house right now because we're trying to get the HVAC started hopefully tomorrow. That way we can get some conditioning on this house so we can start bringing some of the finishes in. But I saw this crazy article, and what they said is that we need to stop promoting air conditioning in houses because of global warming. While I do agree that conditioning and heating and air does have a huge impact on the environment, our houses are not designed not to have heating and cooling. So this house right here, if we did not have any heating and cooling on it, and especially dehumidification, it would fall apart, it would disintegrate within a few years. So when we look at these systems that we're putting in houses, it's not only to make the occupants healthy and keep them happy and comfortable, but it's also to make sure that the structure of the house lasts longer, because we need to make sure that we don't have too much moisture in this wood frame construction or even concrete. You've got to dry things out, make sure you've got enough wetting, enough drying, where the house is going to not fall apart or disintegrate because of moisture. So moisture is the number one thing that contractors hate. We hate it on the roof. We're always worried about water getting in through the roof. We hate it in the siding. This is why you have to have a nice tight building envelope, good systems, make sure that everything is air sealed properly, also water sealed. You've got your water resistant membrane on the outside. You've got your vapor retarding on the foundation walls and underneath the slab. All these systems have to work together, but they only work if you have conditioning on the house. That's heating, cooling, and ventilation. So in this house, we've got an ERV. That ERV is going to bring the fresh air in. We have a Mitsubishi mini split that's going to help condition the air. It's going to heat during the wintertime, cool off during the summertime. But the one thing that most people don't put in their houses, which you absolutely have to have in the South, especially in these warm, moist climates, is a dehumidifier. We've got a Santa Fe dehumidifier in here. This is going to provide dehumidification when the AC is not running and there's too much moisture in the air. So that's going to kick on, take this excess humidity out of the air. That way our structure lasts a long time. We don't have to worry about mold. We don't have to worry about any finishes in here warping, especially flooring, wood and stuff like that doesn't like humidity. So basically keeping an environment where humans are comfortable. If humans are comfortable, typically the finishes in the space will do well at those same temperatures and humidity conditions. So I've got Nikki Krueger. She spoke with us at BS & Beer. So I'm going to kick it over to her, let her explain why dehumidification is important in these structures.
All right, we got a diversified group here, which is great. Thank you for having me. I have a lot of slides just because there's so many areas of a home that we need to consider for humidity control. So we're going to get started. I'm going to go through a little fast, but if you have questions about something on a slide, I'd much rather stop and stay on there and answer, or have a discussion about what we're seeing there.
Should we hold it or go ahead and ask it if it comes
I would ask it. Let's go for it. All right, so blah, 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 20 plus years, unfortunately. Member of the LLC, ACL Manual LLC, which was a high performance home manual. One thing I do want to talk about is real quick on here, and I've mentioned to several, we have developed a 2-day building science hands-on course that's actually held out in Sharpsburg at Reitz Restoration Academy. They have a flood house. We teamed up with Joe Steenbrook, Allison Bales, Paul Hardy from the pest industry. We have a multifamily consultant, and we designed a course that's hands-on, plus you actually encapsulate. So the next one's in October. If you know anybody that's interested, let me know. I can send them. But we talk about building code, and we talk about best practices, and you actually do get hands-on as part of it. So it's a great course. For those not familiar, so Therma-Stor is the company, and these are our brands. You might have heard of Ultra Air whole house ventilating dehumidifiers. We invented whole house ventilating dehumidifiers back in the mid-90s, and they were named Ultra Air. Santa Fe was our crawl space and basement. About 4 years ago, it was decided to bring the brands underneath one, because we had 2 residential dehumidification websites, 2 sales teams, 2 marketing, all that. So we just brought it underneath one. Quest is, are we growing marijuana legally here in Georgia? No, okay. Well, legally, unlegally. Illegally, not un. Quest is our commercial product. So we go up to 700 and some pints, cold storage, storage facilities. So a lot of applications for Quest. And then Phoenix is restoration equipment. So a lot of the patents that you see on those, they're called LGRs, the ones that you wheel in during a water loss. And now we actually have the patents on, had them. I think they've worn out by now. That being said, all of the commercial components used in these dehumidifiers that make sense to use in our residential ones, we use those. And so that's why we have a 6-year warranty with a 5-year full replacement, is because you are getting a commercial grade residential dehumidifier. All right, this one I'm throwing up not because I want you to read this, but because the gentleman who invented, we were the first to invent the horizontal crawlspace dehumidifiers, also for crawlspaces. His name's Ken Gehring, and he's on a forum called HVAC Talk, and he goes by Teddy Bear. And this was, I don't know, it's got cut off there. I think he's got about 13,000 posts on there. He's 84. This is how he spends his time. And he's the first one to tell you when a dehumidifier is not going to fix the problem. He was at the first Joe Steenbrook Building Science Summer Camp. We are really building science focused. If you call me, or a homeowner calls me, or if you call me and say, I have a humidity problem, there is a list of questions that I'm going to ask before I say a dehumidifier is the right solution, because we want it to be successful. But I highly recommend, I think like I said, he had like 13,000 posts on there. A king needs a queen. We'll talk about that a little bit later also. So just so we're all on the same page with some definitions, a pint's a pound the world around. You need a 70 pint dehumidifier or 70 pounds. It means the same thing. This one's really important as we get into more of our high performance, tighter homes. It takes approximately 1,054 BTUs to remove 1 pint of water. So when we get into, our passive house, tighter houses, and I think Carl experienced this in his house, we generate heat as a byproduct of removing moisture. And so that heat, if we're not careful about where we're putting it, can affect the comfort of the home. And then of course, when it comes to our ventilation, 1 CFM out is 1 CFM in. So some thermodynamics, hot goes to cold, wet goes to dry, and high goes to low, which, during our spring, summer, and fall, this is what we're dealing with the pressures on our house. Now, obviously in the wintertime, our house is like a hot air balloon, right? Like everything's trying to get out, but in the hot, humid season, everything's trying to get in the house. Well, we typically say that if you live in a green grass climate, meaning if it rains about 1 inch a week or more during the spring, summer, and fall, you're probably going to have some sort of dehumidification strategy. And as you can see here, we like to go by dew point maps. Teddy Bear, Ken Gehring, likes to put these together. This was late September, and as you can see in this orange area here is really where we're going to have to focus on some sort of dehumidification. September 25th, even in the climates that we consider more of the hot and humid, we're probably not running at our peak load condition to be able to handle the moisture. Shoulder seasons, overnight times.
You mean handle the moisture with the air?
With the air conditioner, right. Yeah. If we're not running the air conditioner, it's not doing anything, right? Now we're seeing that more and more in our tighter homes. Even when we're right sizing, we're partial load conditions a lot of times. So, and this pretty much coincides with our climate zone map being on that moist area over there. So, a lot of times I hear, oh, you live in Florida, you probably need a whole house dehumidifier. Well, the reality is in, you know, maybe a 1980s, 1990s built home that was probably leakier, we're probably running a fair amount of air conditioning in order to be able to handle the dew points down here. But as we go farther up north, I mean, we have 70-degree dew points and probably not hitting the temperature we are in Florida. So again, it's not just a hot, humid climate. It's really all the way up here, all the way over here. How am I going to handle the moisture if I'm not running air conditioning? Whether that's a basement, a crawl space, an attic, that situation. All right, so what are we trying to provide our customers? Comfort, health, property protection, depending on who your customer is, liability protection, and to do it as energy as efficiently as possible for our homeowners. So what are we asking the HVAC system to do? Because a lot of times homeowners think that's my comfort control center, right? That thermostat that I'm pushing up and down the arrows, it's my comfort control. They're looking at as heating and cooling a lot of the time, but really this is everything that we are trying to achieve with this system. And as soon as the house is uncomfortable, who's the first person that gets the call? The HVAC contractor from the homeowner typically, but then you're going to get the call. So yeah, we're asking our HVAC systems really to achieve a lot to keep our homes comfortable, and we need to think about that more and more. I don't know if any of you have heard of a gentleman named Brian Orr. He's down in Florida. He has a website called HVAC School. He is educating the techs all over the country and advocating that we bring HVAC contractors in very early into our designs of new homes, because they're the ones that are going to get the call when your homeowners aren't comfortable. All right, so we're going to kind of focus on these today: the cool, dehumidify, ventilate, and as energy efficiently as possible. So I'm just going to throw these all up here because there's a lot of them. I was on an email chain with a builder, an architect, an energy rater, a homeowner, and an HVAC contractor. And I don't think the attorney was brought in yet. But there was a home, and it was in New Hampshire. It was built very energy efficiently, and they had high moisture issues. And of course, the first thing when you talk about a home having high moisture issues, everybody starts pointing fingers, right? Somebody did something wrong, and it wasn't me. And the reality is, there are so many things that can contribute to a little bit of moisture that you might not ever be able to pinpoint the one thing, when a handful of these can contribute to a lot. So you're getting a little from all over, it's adding up to a lot, and you might not ever be able to exactly pinpoint where that moisture is coming from. So I think we were able to convince the homeowner that, you know, putting in a dehumidifier and they did everything right. You've got a tight envelope. The system was sized correctly. They're ventilating. They did everything right. But when you do all those things, sometimes probably most of the time, depending on where you live, you're going to have to add some sort of dehumidification for when that AC is not running. And also, you know, there's a lot of contributing factors. I think the biggest one, you can design a system perfect. You can install it perfect. It can be commissioned to say, yep, everything's great, and then you hand it over to the homeowner and they have access to that thermostat, then all bets are off. But you're the one that, you know, is responsible. All right, is it going? Oh, there we go. All right, so a lot of sources of moisture. New construction is a big one. Wood frame construction could have as much as 2,000 pints or pounds released by the lumber, concrete, foundation, and drywall as they dry out. So coming from Wisconsin originally, and working for one of our major competitors up there, April Air, who was humidifiers, I always lived in older homes that I was like, there's no way you can convince me that I don't need a humidifier in the wintertime. But even in northern climates now, we're seeing that in tighter homes, in the wintertime, they're having humidity issues. But for sure, for the first 2 to 3 years, you don't want to be running a humidifier in a new construction home because there is a lot of drying going on. Seasonal storage effect, this is where our materials will start absorbing in the spring the moisture from the rain, and then we have all summer long with the humidity, and then come fall, usually about August and September is when my phone starts ringing because we're seeing the evidence of microbial growth. Because the drywall, maybe we have some wood flooring, we start seeing that evidence, and there's just nowhere for it to dry. It can't hold any more moisture. And then of course, basements and crawl spaces are a huge contributor depending on how they're constructed. People, about 1/4 pound from breathing and 1/4 pound from activities. So a family of 4 adds about 2 pints or pounds of moisture per hour in a home. So when we start calculating, okay, we've got ventilation coming in, mechanical or infiltration, we also have to think about how many people are in that space, how often they're home, and what they're doing.
Nikki, I know, jumping ahead a little.
Yeah.
And we talk about high performance, in passive houses is working its way. Are you all actively testing houses now on, because those bottom 2 on that last slide are going to start going away as we build tighter and tighter. The top one probably stays, and occupant behavior is going to stay. And just wondering where you're, like how much.
On the seasonal loading?
Those 2, because that comes from air leakage, and the basement and crawl space moisture comes from air leakage. Like the contribution from those is through air leakage.
I think this seasonal storage effect is going to come, whether it's whether it's mechanical ventilation or not. I mean, even if you use an ERV, you're still going to contribute to that moisture load.
You're loading up the material.
Yep, you're still,
by bringing it in.
yep, the moisture, something has got to control that moisture. And, the whole, and we'll get into this, but yeah, the whole goal of that air conditioner is to remove water when it's running. But the goal of the energy efficiency is to run that as little as possible. So I don't know, I think we're seeing more and more moisture issues for sure. And I think when the houses are leakier, you run the AC for a long period of time. And we didn't see the moisture issues in older, leakier homes that we do now. Because if you wet and dry, you're okay. But when you're wetting, and there isn't a dedicated drying is where we get into trouble. So yeah, we do a lot with passive house. But yes, I agree that, so homes need dedicated, we talk about indoor air quality and indoor air quality products, we talk about ventilation. That's for our health. The only reason we ventilate is for human health. But when it comes to dehumidification, there's a lot of reasons why we need to dehumidify. We have comfort, we have health, we have property protection, liability protection, and we're seeing more and more of partial and no loads on our homes the tighter we build. Can't control people, and it's the only way to ensure that 50%. And we'll talk a little bit more about that 50%. So just in case you don't know how a dehumidifier works, it is an air conditioner in a box. So the evaporator coil, the condenser coil, the compressor, the fan, everything is in that box. So we do, when you have the outside unit, you're discharging that heat outside. We'll still have the heat in our airstream here when it comes out of the dehumidifier, and we'll talk about how to deal with that a little bit more. But everything's in the box. The difference is our coils, a typical air conditioner, about 59 degrees for that coil to condense and get water out. We're going to get just above freezing. So we are focusing on getting to dew point as fast as possible and lower, and removing as much water as energy efficiently as possible. So that's the whole goal of this unit is just to remove water, and that's why those coils get so cold. Am I on the right? So we talked about mold and all these benefits of having a dehumidifier, and why we've seen, you know, we invented these in the mid-90s. We were the only ones on the market for quite a few years. A lot of people don't know that we actually manufactured Honeywell's units when they first came out with them for 10 years. And then they took them over to China, knocked it off. It's funny because Aprilaire and Therma-Stor, or Research Products, are located about 2 miles from each other in Madison, Wisconsin. So both of our facilities are in the same area. They came out with a dehumidifier, I think it was the early 2000s, like maybe around 2009, 2010 frame. So we kind of established the market, and then others started coming in. And the reason being is everybody's seeing the need for it. Manufacturers don't get into this game unless they actually see a need for it. And I will tell you what, the need has grown significantly, and it's not going to go away. Now, whether it's always going to be a dedicated dehumidifier or, you know, I water furnace back here, gentlemen. You know, I know there's reheat in those. Whether it's a reheat system, we are reheat. This is basically a dedicated box of reheat in order to remove that moisture. Whether HVAC manufacturers start putting in more and more, I don't know, but we'll definitely see that probably happen. The challenge is getting the contractors, HVAC contractors, to be able to be educated on those systems and work on those systems and install them correctly is a little bit of a challenge. So our manual J's. Our manual J, when we run those, we are running them for our peak cooling at 75 degrees and 50% relative humidity. So in the IECC code, the energy code, you cannot supposedly fudge your manual J to go below 75 degrees. We all seen it happen. I look at a lot of manual J's. But we are supposed to be designing to 75 degrees and 50% relative humidity. There's comfort reasons for that. There's health reasons for that. That 50% relative humidity is definitely a big health reason during the humid season. But that's the goal for us when we look at sizing dehumidifiers is if the AC is not running at peak load condition, how can we control that home to 50% relative humidity? How often do our AC systems run at the peak cooling loads?
1%.
About 1% of the time. So we're designing our systems and sizing our systems based on 1% of the year. So how are we going to manage that 50% relative humidity outside of that?
Just by the way, BS recommends 77
On the cooling, BSS? Yeah. And, you know, there's people, everybody gets so fixated on a number, right? I mean, that you're like, no, if you add that dehumidifier, you don't have to keep your bedroom at 66 degrees. So I stayed in a hotel in Noonan last night, and the thermostat up button would not go up, and it was set at 66 degrees. And it was muggy, it was uncomfortable, it was horrible. And in the South, that's all the time, right? You walk into hotel rooms, and it's like stuff just feels soaking wet. But that 50% is really what we're focusing on. So, and I've seen this with a lot of energy efficiency programs where everybody wants a really high SEER HVAC system, right? Because that's the most energy efficient system that I can get is when there's the higher SEER. So some of the challenges that we see with these higher SEER systems is they have larger coils. And they're very energy efficient at getting to a cool temp quickly, which means less runtime. And these coils hold about a pint or a pound per ton. So if you have a 3-ton system, you got 3 pints of water on those coils. The coils don't get as cold. You know, I think there is a DOE net zero energy webinar that Ken Gehring did out there where it's titled The Lazy AC. And basically he has said we have made our air conditioners lazy. By not setting those coils down to 49 degrees, we're setting them at 59 degrees. And we're not removing the moisture that we used to. Yep?
Does the dehumidification problem get solved by having variable speed equipment?
We're going to talk about that because that's a hot topic. The high efficiency, so they used to kind of cheat the SEER by when the compressor would shut off, the fan would run for an extra 1 to 3 minutes. So if you would get credit for evaporative cooling. You don't want evaporative cooling down here because that means all the water on those coils is being blown back into the house. So most systems you can shut that off. Now, I know Carrier was one of the first ones, but I'm pretty sure most of them can be shut off now. But we want to make sure that that's shut off. But when that happens, it can increase the relative humidity by 10%. So basically, everything that you just did to remove that moisture by running the air conditioner, we just re-evaporated back in that house because per ton, there's a pint of water on there that's being re-evaporated back in.
The nest feature you have to turn off to keep that from happening.
You do? Yeah.
It's default built in.
And
Be great if we
HVAC,
were dry here.
HVAC contractors hate Nest thermostats. So, but homeowners love them. That's the challenge. But yeah, you have to make sure. Yep. Okay, so we're going to talk about sensible heat factor here because this is one of the questions that if someone calls me and says I have a humidity issue, I'm going to ask them what the sensible heat factor is of their AC equipment, and that basically is going to tell me when it's running, how effective is it at removing moisture. And just to show you here, we have got some AC equipment data here. So right here we've got a 14.5 SEER air conditioner. The sensible heat factor is 0.62. So that means when this system's running, 62% of the BTUs are going to the sensible cooling, and 38% are going to the latent cooling or the water removal. So when this system's running, it's doing a really good job of moving moisture. Here I've got a half-ton mini slit, 33 SEER, 0.96 sensible heat factor. So that means when it's running, 96% of the BTUs are going to cooling and 4 going to water removal. Yep?
But the problem is when I size a system, I have to size it for sensibly.
Yes.
So if 62% of 33,200 is my sensible capacity, I might need to bump my unit up a ton to compensate for that, which now puts me in a situation where I might be oversized.
Absolutely.
And that's the conundrum.
That's Santa Fe has a solution.
And we're seeing it more and more. Yes.
So this would be a question as much for the whole room.
Yeah.
So if HVAC contractors are designing to the manual J, and my wife has a comfort range at night it's 69 degrees and the day is 71 degrees, which is nowhere close to your manual J calculations.
What is your RH in the house?
Well, we got it set for 50.
You have what?
Is it 50 though?
Huh?
The relative humidity is what in the house?
We have it set for 50%.
Oh, you have it set on your thermostat for 50%.
Yeah.
Do you have a dehumidifier?
I have 3D.
Oh, well, okay, well. I was like, are you using it as overcooling to dehumidify, or if you're using, okay. So,
That's really cold.
that is really cold,
Yeah, it's cold when it's that dry.
but good for, yeah.
Sleep under any covers.
Yeah, because
Ceiling fan.
typically, when you control the relative humidity, you will be more comfortable at a higher temperature, right? That's Arizona versus Florida, typically. But every person's different. I will say that there are times in your life where every person's different, you know, typically as well. So, you know, and what men and women, you know, there's often the thermostat wars. We've all heard that. But yeah, it's challenging. But usually, you know, this just points out, which I think we see a lot of these energy building programs advocating for higher SEER for energy efficiency. The higher the SEER, the higher the sensible heat factor, which means the less water going down the drain. And we've got to be thinking about that, because you can build the most energy efficient house, but if it's not a comfortable, healthy house, it doesn't matter how energy efficient it is.
And Manual S says, if you can't achieve those things, it says you should consider supplemental dehumidification.
And Manual
I've been
S,
saying that for a long time,
and
and
yeah.
everybody goes, well, they're not gonna buy that. So I'll do something else.
So the new Manual J also says that if you should get the partial load data from your equipment manufacturers to know if you're going to need dehumidification, which I don't know about you, but I had to go like Secret Service to get this information. You know, trying to get partial load or get performance or any, it's
You mean like on a 2-speed, or you mean adjusted design condition?
on the partial load design conditions. Yeah, yeah. So, all right, so we talked about this. The goal is to run the largest system as little as possible. We're using higher SEER. We have a lot of partial to low loads on the AC systems because we're building so tight, right? We're doing a great job. We're getting better sensible cooling, but at the expense of the latent removals. We got to focus on that water going down the drain. So our dehumidification strategies, we got single stage. We've had a lot of builders go, you know what? I'm going back to single stage or just 2-stage and adding a dehumidifier, keeping it simple, taking care of it. We got variable speed. Jesus. Sorry about that. We got variable speed equipment, whole house dehumidifier, and then we got mini splits. So air conditioners, again, going to get to a set point. Really, it's not the hot, humid days that we're focusing on. It's that 70 and raining, or those shoulder seasons where we're not running at peak, that are going to be the most challenging. And typically, for an HVAC system to get effective dehumidification, you need 14 minutes of runtime for those coils to load. Remember we said they're larger coils? So you need 14 minutes for those coils to load before one drop of water goes down the drain. So you really need about a good half hour of runtime to get really good dehumidification and control in that house. And a lot of times now, you know, when we're building, we're not running that long. Variable speed slows the air conditioner fan down to remove more moisture. AC makes smaller amount of colder air. Again, no matter what, if it's not running. We have the potential of getting to these colder surfaces, right? So we're slowing that fan down, we're creating colder air, and then we have the potential of condensation issues. There was a project that a homeowner in Northern Virginia, it was not condos, townhouses. I think they were one of the first lead townhouse projects in the country. And the homeowner reached out to Teddy Bear on HVAC Talk because they had 3 levels in their townhouse. The bedrooms were on the 3rd level, and then there was another family room upstairs. In their bedroom, along where the ductwork was, it had all condensated, and their ceiling was starting to rot out. So they pulled it out, and the ductwork was insulated, but the challenge was, and my husband, who one of the largest energy raters in Northern Virginia, saw all the time, is they would insulate that ductwork, but getting to on the top there can be very challenging to get that sealed and completely insulated. So what happened is we went over to on the sidewall here. First of all, I could totally smell the weed that the people in the townhouse next door were smelling. But when they had opened up the ribbon band over here and you pulled out that fiberglass bat, and it was all black. So the air infiltration coming into that cavity was hitting that cold ductwork, condensing, getting caught, and then dripping. And so there was 3 bedrooms upstairs. That was the master. They had ripped out all the ceiling, all the drywall. And the builder came in and said, well, we'll just go ahead and spray foam that ductwork. And so my husband, who was involved in the project, also said, so it doesn't matter. That air is still going to make its way to the other 2 bedrooms up here where that ductwork isn't spray foam. So that's not the solution. But it's that colder surfaces that we could potentially create. And then we'll talk about some other things with variable speed. And actually, I'm just going to go to it because we all just already agree. Don't use dehumidification mode on a mini split. It's a timer-based system. Their condensate lines are very tiny. When you hit dry mode, it's just going to run typically based on a timer and create a lot of cold air and not remove any moisture. So small spaces, if we're going to do moisture loading, that's what's going to contribute to that moisture loading, and we're going to see microbial growth typically. So variable capacity equipment, their supply temps are typically higher. Their sensible heat ratios or factors are higher. And no matter what you do, 2/3 of the BTUs are always going to go to cooling and 1/3 to water removal. So if you're trying to use that variable capacity to remove more moisture, you're still creating more cooling than you are water removal. And I'm going to direct, and I don't know, there's probably an email that goes out after this, but there is an article, and I think I did a podcast with Brian Orr, and he talks about compressor ratio. And basically, one of the ways he describes it is if you take a really wet sponge and you squeeze it, a lot of the water comes out all at once, right? And that's basically when we start our HVAC systems, we're going to load up those coils. As they're getting colder and colder, it's going to remove a lot of water. The closer you get to that temperature, that steady state temperature of where you want to be going through that system, your sponge is still wet, but we're not squeezing any more water out. So it's, we get the biggest bang for the buck when we load up, when it first comes on and runs for a little bit and shuts off, than we do if we're just running at steady state all the time. It's still wet, we just can't wring any more water out of it because we're still at steady state. Yep?
Some of those systems have active dehumidification though, where it will actually ramp the compressor speed up a little bit and slow the fan speed down a little colder to combat what you're talking about.
I will direct you to some data from a gentleman named Tim DeStasio in North Carolina, and then actually I just had an HVAC mechanical designer call me last week out of Houston and say, I've been data logging and looking at the data, and those systems are not doing what they're saying they're doing when it's the data that's in the field. So happy to supply links to those data as well, because he's like, did you know this? I'm like, yeah. He's like, I can't believe this.
That's just what they tell us.
That's what they say. That's what they say. But yeah, I will definitely, to me, it's the data. I'm not going to go, I know how these things work, but having the real world data is what really shows what's going on. I don't know how I'm doing on time here. All right. So a whole house ventilating dehumidifier, if you're not familiar with one, basically we are going to dehumidify the entire home regardless of AC runtime. It's controlled by a dehumidistat or a humidistat, if we want to call it that, and it is going to run this dehumidifier when the relative humidity gets too high in the house. Ideally, we're only using the supply ductwork of this system to distribute that dry air through the house. And so we'll talk about install and how that works. Now, how much dehumidification you might need? Yes.
Are we going to talk about the ventilating dehumidifier more later?
Yes, we're going to talk about it. Yep. Yep.
I was given a list of questions by somebody that.
Oh boy. Okay. So we have got a app. It's really old. We've had it for a long time. Basically, all of the operating systems have said you're old. Maybe you can find you, maybe not. So it's either underneath Ultra Air Psychrometric Calculator, Santa Fe Psychrometric Calculator, and it's going to be an old school Santa Fe logo that has like rays, or you might find it underneath Phoenix Psychrometric Calculator. The colors in the logo are going to be different. That's the only thing. All of this is the same. How you use this is the inlet is going to be what the conditions are outside. So what's going on outside? The outlet is going to be what do I want it to be in the house. So here I said the inlet's 85 degrees. There's a 61% RH, and then it's going to automatically populate the dew point, which a lot of times I just use this to get what the dew point is. The outlet is 75, 50, 55 degree dew point. That's what I'm going for. The flow is what is my ventilation rate? Or maybe if you're not running mechanical ventilation and you do a blower door test, you can see what your what's the infiltration rate I have. Based on that, it's going to tell you how many pints of water removal you need a day, or you can switch it, and this little I, you can switch it to pounds per hour. So just based on your ventilation or your infiltration, this is going to tell us how much dehumidification we need, which is really important because then that is going to help us determine what is our dehumidification strategy, right? So if we're not running at peak load, 85 degrees out, tighter home, we're getting to that thermostat setting quicker in a tighter home, which, to be honest with you, code-built homes now are becoming pretty high-performance tight homes. We don't have to go, all the way to the extreme of passive house anymore to get a pretty tight home. You're going to get to that thermostat set point faster, and your house is going to hold that set point for a lot longer also. So, 85 could very much be, partial load to low load for quite a while. But this is just based on ventilation, and then depending on how many people in the house, we could add that to this number to try to get really how much dehumidification I need.
Can you oversize that dehumidifier?
Yes, you can. Yep. We are, just like an air conditioner, we want longer run times. Instead of start and stop and start and stop it, we have to load those coils up. Now, they're smaller coils and very energy efficient, but we want to load those coils up and get longer run times. So I always say we've got some literature here that gives you performance data. If you're kind of on the edge, I would always size up because you don't want a homeowner to pay for something that isn't doing what we said. We'd rather have a little bit more capacity than we need. Because we don't know all the factors. We don't know exactly everything that's going to contribute to the moisture in that house. So it's always better to have a little more. This is extremely important to understand when it comes to sizing dehumidifiers and really knowing what you're getting. So up until 2019, the DOE had us testing our dehumidifiers at 80 degrees and 60% relative humidity in order to get what our capacity was. So this whole home unit and this Crawlspace unit, 70 pints each, and at 80 degrees and 60% relative humidity, we would be at 70 pints. And then in 2019, the DOE said, well, maybe indoor pool conditions aren't what we should be using for residential homes. So they changed the testing conditions for whole house dehumidifiers to 73 degrees and 60% relative humidity, so more realistic to our homes. And then for the standalone or portable units, they changed it to 65 degrees and 60% relative humidity. So basements, crawl spaces, those conditions below the house are probably going to be cooler than what's in our living space. So what does this do? 73 and 60, a whole house unit goes from 70 pints to 55 pints. So as soon as you lower the temperature of the air, the capacity of that dehumidifier goes down. So you're not getting 70 pints. And then a crawl space basement unit at 65, 60, that 70 pint unit goes down to 40 pints. So when we're looking at how much dehumidification we need to understand the capacity of the units. And that's why on our website and here, we are the only manufacturer that basically lets you look into our underwear drawer and see the not so good. But every dehumidifier is this way. It is not just us. As soon as you lower that temperature, your capacity is going to go down. And we want this to be successful. We want the install to be successful. So we try to give you as much information as possible. We'll talk about ventilation and using our dehumidifiers for ventilation here because we are a whole house ventilating dehumidifier. So we can bring in outdoor air. We'll start with the hot climate here. This is usually a 6-inch duct. This is either an 8, or this is usually a 10-inch duct on these units that have dedicated ventilation. When the fan comes on and says, okay, based on our ventilation control, we're going to activate the fan. The fan's going to come on. It's going to pull air from the outside and air from the return of the house. It's going to mix that air in the box, filter it through a MERV 13 filter first, mix that air in the box, and then deliver it on the supply side, hopefully, of the HVAC system. So when we say we're ventilating, we're not automatically just bringing in 90-degree air and putting that 90-degree air into the supply of the HVAC system. We are tempering that air in the box with the return air from the house and then delivering it to the home, which is really important to understand. Now, if the compressor's running because the controller in our house says we need to activate and dehumidify, and then we are ventilating at the same time, we will remove some of that moisture coming from the outside at that same time before it enters the house. But what we really care about is what is the relative humidity in the house in order to run the compressor on the dehumidifier. Because it could be 90 degrees out at 3 o'clock and your air conditioner's already going full force, and we're going to bring in outdoor air. We might not need the dehumidifier because the air conditioner is doing a really good job of dehumidifying. And that's where it comes in that AC is king and dehumidification is queen, right? We want that air conditioner set up to remove the most amount of moisture it can when it's running. So AC is king. Teddy Bear says when the king's sleeping, that's when the dehumidifier becomes the queen and will take over that water removal.
Nikki, so when you have a controller that runs this thing, it's the controller that, is the controller sensitive to humidity in the house as opposed to in the unit?
Yes, yes. We usually, like a lot of thermostats now, will have relative humidity control on it.
They connect to this.
And they can connect to this. Now, a lot of the thermostats don't have where you get multiple options of IAQ products. So it might not have ventilation and dehumidification. But we have it's called a smart air power damper, because you're usually going to use a power damper on this to open when it's ventilation time. So we have a smart air power damper that you can work in all the ventilation logic. You can just 62.2. It'll have lockouts if you want it, too hot, too cold, and that can just run the ventilation. And then, or we have a controller, our own separate controller that has ventilation and RH that will do both. So, and I think that's one of the a really good point, because a lot of times people say, well, I don't want to bring in 90-degree air to my house, so I want to lock out, right? If it's too hot, I don't want to ventilate. If it's too cold, I don't want to ventilate. To me, you ventilate because people are in the house and you need fresh air or outdoor air, not fresh air, outdoor air, because we don't know how fresh it is. But to me, if it's 90 degrees outside and humid and my AC is running full bore, that's when I should be ventilating, because I have the largest system in the house, the biggest dehumidifier already going. That's when I should be ventilating. People are like, oh, we'll ventilate overnight. Well, that's when the dew points, we have the higher dew points and we are not running the AC. And that's when everybody gets up and starts cranking down the thermostat because they're uncomfortable. So, but yeah.
Would this be used in conjunction with an ERV, or like it's a replacement of an ERV?
So we're going to talk about ERVs. Do you know Matt Reisinger at all from the Build Show?
Sure.
So, what Matt likes to do is, ERV for ventilation, a dehumidifier for dehumidification. Keep them separate, let them do their own thing. But if you can't afford both, then he says use the ventilating dehumidifier. Now, there's an article out there which I can give you that a former colleague of mine wrote, David Shrelevin, in Green Building Advisor, because we often get asked, well, can I connect the two together? And he gives, I think, three different scenarios of how you can connect an ERV and a dehumidifier together, the pros and cons of each. But the reality is we have fans, they have fans, static pressure can be an issue. It's easier to keep them separate.
Why jump into supply rather than, supply rather than input?
Yeah, that's the one I've been waiting for. I think it's coming up here. I'm just going to talk about ERVs quickly. This was a house down in Florida. I think it was NHB Emerald Green. The equipment manufacturer was supplying the ERV, so we did some data logging. We have partial load conditions going, a spring week of rain. This blue here is the RH in the family room, and it's going above 60%, high 50s. The dew point outside, this is the green line. Basically, you can see the RH is following that dew point outside. We ripped out the ERV. We could have left it in, just let it do the moisture removal, because an ERV with that enthalpy core is going to lessen the load of moisture, but it's always going to contribute to the moisture during the humid season. So it's definitely going to lessen it, but it's still going to add to it. So we just completely removed the ERV, set up the dehumidifier to bring in the ventilation, and we just set the RH, and we don't care what the dew point is doing outside. The dehumidifier is just going to come on and dehumidify that house and keep it to a set RH. So ERVs are not dehumidifiers. And again, the Cadillac would be an ERV and a dehumidifier, but it's always going to contribute to the moisture load. All right, let's see here. We are going to go into install. All right, so our recommended install is a dedicated return to the dehumidifier. You don't have to use this for ventilation. If you have another ventilation strategy, you can just cap that right off, not use it at all. And then we are going to tie into the supply of the HVAC system. This install is the most energy efficient way to install a dehumidifier because we don't have to run the fan on the air conditioner when we set it up this way. So it's the most energy efficient. Our fan in here is going to tie in and just blow that air right through. So this is our recommended install. Yes?
Does the fan in Santa Fe have enough static pressure to overcome the static pressure in the supply?
As long as you don't go above 0.5 on the supply side of the supply ductwork. So if you're above 0.5 water column, it won't be able to handle it.
What about when your builders squish all your duct with LVL?
Yeah. Well,
We shouldn't work for those guys.
yeah.
Then we'd be broke.
And we got to make sure we got a backdraft damper in here. I often see this one mist, but you got to have a backdraft damper in there so that air isn't coming out and going back through the dehumidifier. Now, this is what it looks like. We've got our fresh air, return air. If you read Allison Vale's book, you probably saw this picture in there. We need a good P-trap on this unit. MERV 13 filter there. You can access the filter on both sides. All right, let's talk about tying into the return. I assume that's what you were talking about. Okay, so whether you pull a dedicated return to the dehumidifier and tie into the return, or you pull from the return of the return ductwork for the AC, it's in our manual. It is the very last recommendation. I think we have 4 or 5 installs. And this one you're going to see a bunch of cautions and warnings about doing it. And the reason being is that in 2018, Florida Solar Energy did a study and basically came back and said, going on the return side of the AC system is the most ineffective and inefficient way to run a dehumidifier. Why is that?
Dehumidifiers for the coil.
We are generating heat. The air coming out of that dehumidifier is about 15 to 20 degrees warmer than the air going into it. So when you put that heat in front of your AC coil and load up that AC coil can't get to dew point anymore, because that's what's going to happen when you put 15 to 20 degree heat over that. You're not going to remove the moisture that that air conditioner was sized for in order to be able to handle the latent loads in the house when it's running. Then when it shuts off and I have a 3-ton system and I got 3 pints of water on that coil and the air conditioner shuts off and then the dehumidifier says, oh, well, the RH is still too high, it's going to evaporate all that moisture back into the house. In Florida, as of 2022, by their building code, you cannot install a dehumidifier on the return side of the HVAC system in Florida.
You know, in the April Air Manual, that's the recommended.
I know that very well, yeah. Yep, that's the recommended. I don't know why. I've heard some theories out there. I think there could be a static pressure question about that, but that is not, our recommended has always been to pull from the you can pull on. I mean, we can pull from here and then go into the supply. We're going to have to run the fan on the HVAC system or have this elusive check damper. I've never seen one in the field, but you would just have to run the fan if you pulled from here. But if you pull a dedicated return and go into supply, but yeah, in Florida, you're not allowed to do that anymore. And I've had 3 summers ago an HVAC contractor call me and like I couldn't even say a word. He was so angry that he installed our dehumidifier 2 weeks before and the RH had gone up in the house. And he was, he convinced that the dehumidifier was dead out of the box, didn't work, asked how he installed it, return to return. He went in and put it on the supply side and it worked fine.
I think the problem with the other method though is you've got other things like zone dampers and things that, get sticky, get messy, and then your static pressure as well.
Mm-hmm.
If you suck out of return and blow into the supply, now you create a situation where it can actually run backwards to the dehumidifier.
That's why you got to have the fan running on the air handler.
Yeah. On the left.
On the HVAC system, on the AC, we got to have that fan going when the dehu's going.
Right, and now they're competing against one another for static because the fan could technically suck. If the return plume is in a very high negative state of pressure, it can suck air backwards to the dehumidifier and basically create a short cycle situation.
And this is why it's so clean.
Yeah, it is, except if there's a zone damper where that draft word on backdraft damper is, then
now you gotta set it up so the damper opens, or the humidifier kicks on, and it creates other headaches.
Or you just go in after the damper.
Or decouple, if you have room for that.
Yeah. Oh, yeah. I mean, there's a lot of, it depends.
You just drop it back into the conditioned space. You have like a 2-story townhome and you've got an open stairwell.
Yeah, I was gonna say.
If I've got no zoning, I don't wanna redistribute it, but if I've got zoning or there's some complexity to your point, I would pull my intake from a shared, return location and then just drop it in a stairway and using a separate independent control. You're just making a bunch of dry air to put in the house that mixes with the other air
Absolutely.
that then eventually gets leaked out.
You guys are okay.
You don't have to worry about CFL.
Dedicated supply.
As long as you're not blowing it over people.
It's like 100 degrees.
Exactly. So we're seeing it more and more where, especially like the open stairwell or, like cathedral ceilings and stuff, like giving it its own ductwork. Matt Reisinger is doing this more and more in his homes. He's just putting it at the ceiling. No one's gonna feel it. And the great part about that is water vapor is lighter than air. So the RH here on the floor is always going to be lower than the RH at the ceiling because that's where all the water vapor is going.
So here's what'll happen next. A home inspector will come in and shoot it with a little laser beam and say, that's not working.
Well, it's going to be much drier up there.
We've got a home inspector in here.
It's supposed to be air conditioning on.
Yeah, yeah. It's going to mix though fairly well. I mean, hot and cold, wet to dry, it'll mix. But yeah, that is like the cleanest way to do it. And then you don't have to worry about static.
So Nikki, a home with a dehumidifier is going to take longer to cool down than one without because you're mixing the warmer air from the dehumidifier in the supply.
So you're looking at, like that unit right there is 100 with, if I had some static on it, let's say 135 CFM. The amount of air going in at that temperature is pretty low. We just got to make sure that our duct design doesn't have the first supply duct right over the lazy boy in the living room, right? There's duct design. Most of the time, unless you're in a higher, like passive house, as long as we get our duct design right and get mixing. And so what I say, especially in high performance homes, is run the dehumidifier and the fan on the HVAC system at the same time. You're going to get better mixing in that supply, better filtration, all of that. Because a lot of times we're seeing more and more a lot of these high efficiency air cleaners being added onto HVAC systems, right? And we're running those, fan all the time in the spring, summer, and fall on our HVAC system. Well, what does that do to the water on the coils? Evaporates all that water on those coils back into the living space. So the dehumidifier helps with that. That's one of the things that, people call and say the humidity is high. Are you running continuous fan? Well, yeah, I have a high efficiency air cleaner because we have allergies. Well, shut that off. Well, I'm not going to shut that off. I just paid $2,000 to have it installed. So the dehumidifier will help with that. But it's also one of those things too that we might have to activate that fan, even if it's on low speed, just to help mix that air a little bit more. It all depends on what the duct layout is and that sort of thing. Typically, we don't see any issues until we get into these tight homes.
Somebody made a dehumidifier, it was either Ultra Air or Santa Fe, I can't remember, that had a outdoor condenser.
Oh, yes.
Do they still make it?
The SD12. It was Ultra Air, which was us, right? Ultra Air and Santa Fe are the same company now. Yeah. Yes, we made it. And of course, we hardly had any sales of it, but as soon as we discontinued it, everybody's like, what are you doing? It's like, well, nobody's buying it, but it is great because it discharged the heat from the dehumidifier outside. So you had a 1-ton unit outside, and then it tied in, but it was 180 pints. So it was a girthy girl. It was, and so it was big. I would love for us to relook at it and bring it back in smaller sizes. if possible. We'll see if that happens, but yeah, it was a great unit. I just spoke in Houston last weekend, and that's one of the questions. I get it every single time. So up north, in really tight, like passive houses and stuff like that, they were using that for dehumidification and cooling because they didn't need a lot of cooling. So they were just getting that by. Now the challenge was they needed a lot more dehumidification in the shoulder seasons and not the cooling. But now they were getting cooling as a byproduct because up, in the shoulder seasons, when you start.
It's like running mini splits in the dehumidification mode, which is like 55 degrees.
Yeah.
See, in that case, like when you're running it in a cooling climate, you have to recool. In that case, you have to
reheat.
Yeah.
Exactly. So, all right. We have an in-wall dehumidifier. This is a house in Texas. I think it was actually passive house. No duct work. We have an in-wall unit. Oh yeah, you had a question. Sorry.
Yeah, sorry. So going back to, running the air handler.
Yeah.
What are the controls?
So on our DH3000 controller, you can interlock those two. And I think with some relays, you can do it as well.
Okay.
So there's no control, there you can send a wire from this to the air handler to kick on the blower?
Yeah, from our controller, the terminal block would go to a controller, the DH3000, and that DH3000 then would go to the air handler or the fan on the air conditioner to run. So it does lock you into using our controller then in order to be able to do that. For that.
You still have the standard, whatever your existing thermostat.
The thermostat, yep. So you would have your thermostat and then the RH ventilation and then that fan controller would be on there that you could do that.
So for a retrofit situation, and I can't run a wire through the wall upstairs and put on a house, that's what I like about the Air is that it's got the controller built onto the unit. It samples the air and it monitors humidity at the unit itself. Do y'all have anything like that?
So it's sensing the RH.
The air sucked through the unit.
Here.
Yeah.
And this is located in an attic or a crawl space that have completely separate conditions than my house. So if this is located in an attic and I've got 160-degree air in my attic in the peak of summer, and I've got a piece of flux duct insulated coming to it, by the time that return air comes from the house to this dehumidifier, and as soon as I increase the temperature, I lower the RH and the sensor is going by RH, I am not getting a good reading in this dehumidifier of what's actually happening in that living space.
But the problem is just logistics of running that wire and mounting the stack on the wall makes it challenging. I didn't know if your stack, I know y'all sell the separate stack.
Yeah.
I didn't know if you could like literally mount it on a duct and have it sample the air.
I mean, I've seen it. If I was going to use the return, like I see this in multifamily all the time, where they'll install a 70-pint unit. They don't want the residents to have any control of the dehumidifier, and they will put the wired humidistat. They'll take the filter out of here, do a wall grill filter, and put that humidistat right behind that filter, because I'm as close to the living space as I can get, because it is if you're in a conditioned or a closed conditioned attic situation, it probably won't be as different. But there's a reason our thermostats are in the house, and so and then a homeowner who's paid for this and is concerned about the relative humidity, because more and more we're seeing homeowners very concerned about the RH in the house for health reasons. They're going to start going to Home Depot or on Amazon and getting all those humidistats and putting them all over the place and saying, well, I thought you set that to 50% or 55. Why is my master bedroom with the ensuite reading 65? You will always get better control in the space, but it can be a problem.
In D33, I mean, I know I looked at real low end. How loud is that unit?
So it's about, yeah, on our spec sheet and on our website, it's about 45 dBA. So it's between a refrigerator and a computer fan. So don't put it in a bedroom.
Darn.
Especially, exactly, I get it all the time.
That's all I want.
Yeah, because that's all you're gonna hear when it comes on at night, shuts on and off. I mean, it's fairly, this is a hallway. We've got bedrooms here. We're using the drain in the bathroom, and then plugging it in. But yeah, I would caution about putting it into a bedroom because now what you can do, and Corpus Christi, we have a resort that is like concrete, all built out of concrete. They're using ductless mini splits and ERV, and then they put one of these in every single one of the rooms. But they were getting complaints from people that it's coming on at night. I can hear it. We basically, for lack of a better term, plug this into a Christmas tree timer and set the RH at 45. So during the day, we over dehumidify, and then we can ride it a little. It'll shut off at like 9 o'clock at night, 10 o'clock at night, and then it rides, overnight. And again, as long as we wet and dry, but even comfort-wise, it should be able to. And I wouldn't go much lower than, you can go to 40, but you're, potential freezing up those coils potentially, but 45 seems to be successful. All right, crawl spaces and attics. Dr. Joe Steenbrook, built wrong from the start, vented crawl spaces, they grow mushrooms. This is oftentimes what we're going in and fixing in crawl spaces. About 50% of the air in the home is coming from below the home. So when you have a crawl space, you've got issues. I worked with Dr. Joe on getting dehumidifiers into code in 2018. We got it wrong. We said 70 pints for every 1,000 square feet, regardless of height. And then, basically if you went over 1,000 square feet, you automatically needed 2 dehumidifiers. It wasn't right. So we went back in 2021 code, and I said, Joe, can't we say just according to the manufacturer's specifications? He's like, nope, it's too simple. It's never going to make its way into code. It's too simple. I'm like, well, let's try it. So we got it in there. A lot of times crawl space contractors will be like, well, we're on 2012 or 2015. I'm like, the newer code edition will always trump if you're doing better. It can't penalize you for doing worse. So you can use the 2021, although your area is on 2012, because it's saying that you're doing better. But one of the issues, that I'm seeing more and more of is using supply, which meets code in crawl spaces. So basically taking some of that supply air, putting it into the crawl space. As part of that code, you've got to have communication between the living space and the crawl space. I've been in a lot of crawl spaces. I've encapsulated a lot of crawl spaces. I don't care what you do to it. I don't want to be sharing that air below my home actively with the air in my home. So I don't like this. One of the reasons, well, here's what a dehu looks like all set up. Get that supply duct on there, good air circulation around there. But one of the reasons that I don't like supply air, a lot going on. So this is 2 habitat houses right next to each other in Northern Virginia. The dotted line is what's going on in the crawl space. So here, this one is the temp. Basically what we see here is the dew point is the blue, and the orange is the relative humidity. So we're consistently above 60% for that relative humidity. These are the conditions that were going on outside. So this was using supply air, and I think this was in April. Yep, we got April going on. I had sensors down there. My phone was beeping all the time. Finally, I just shut them off, but above 70% RH was consistently going on here. This was what? That's just one day, but it happened all spring, summer, fall. We had the house next door. We put in a dehumidifier. both of these had just been remediated for mold because they had just finished completing the houses not too long ago. This homeowner was really concerned about getting mold in their crawl space. They set the dehumidifier at 40%. I had to go back and switch it. But basically, we just want to make sure that we're controlling the moisture with active dehumidification, meaning that we're not diluting with some supply air based on the homeowner's comfort in the living space and running the air conditioner. Typically, our shoulder seasons are going to be when crawl spaces need the most amount of dehumidification, and actually in summer because it's in a cooler area. And again, we lower that temperature, the RH automatically is going to go up. So when we're putting cold air into a cool space.
I was talking to the guys at Atlanta Habitat several years ago, and they had issues because they were conditioning their crawl spaces without separate dehumidifiers, and the owners just were not running the air conditioning to save money.
Yeah.
And they were completely molding up.
And I think it's in one of our spec sheets, we had a senior apartment facility in Virginia Beach where one of the ladies was keeping her thermostat in August at 80 degrees. And the maintenance guy kept coming in and turning it down to 74. And we get there and she is like laying in him. She's like, I should not have to run my pay to run my air conditioning to prevent mold and be comfortable. And she's like, and I'm not. She grabbed her sweater in August and went and sat outside. So put in the in-wall dehumidifier and set that thermostat to 78, and then it was fine. But that's, yeah, so it's always interesting with crawl spaces. I think at some point for code, again, we're going to have to look at if we're counting on supply air to condition a crawl space, an attic, places where we really might need more dehumidification if they're closed, then the temperature shouldn't be that different. The tighter we get, the less AC runtime, the less we can count on some small amount of conditioned air to control that. Encapsulated attics, we're seeing more and more here. They put in 2 dehumidifiers, one just for the attic and one for the whole house. I know that builders and homeowners really like that, two machines now, but very energy efficient. But you know, if we're controlling moisture, we got to think about those spaces sometimes separately. Going to have a secondary drain pan and a float switch under that one in the attic also. That unit right now is our crawl space unit. That does not have a terminal block on it, so you cannot wire a float switch to it. So that one I see go into attics, even in a float pan, but there's nothing to shut it off if it were to leak. So that's why our 70 pint that has the duct collars and the terminal block, they just put that up there and then don't put duct work on it if they don't want to. Huh?
Just when the float switch has an AC control, it was disconnected if the fan fills up.
At the fan, yeah.
A lot of air handlers have that. It doesn't turn off the fan, it turns the power off of the air handler.
The air handler.
You need a relay.
Yeah, you'd have to have a relay. But this one, yeah, you can just, now, let me show you here. Okay, so we have a lot of multifamily applications, or a lot of light commercial applications there that we've been doing as well. This is one of the multifamily units. I want to get quickly to new stuff that's coming out because I know everybody wants to get out of here. We are redoing our ducted dehumidifiers. So we are now going to a 8-inch fresh air duct on our redesigned dehumidifiers going forward. The reason being is we are being used more and more for ventilation, and that ventilation is actually being measured. And so what we were finding is for the capacity of the unit, for the size of the house needed, we were not bringing in enough outdoor air through a 6-inch duct in order to be able to check the box for ventilation and dehumidification. So we were seeing upsizing of dehumidifiers in order to be able to bring in that CFM of outdoor air. So we've got bigger fans, or stronger fans going in with an 8-inch duct. Now again, you don't have to use it, but we want to be able to meet that ventilation code. We will have a digital control up here with a smart air remote sensor. So you will be able to take that smart air remote sensor, put it in the house, put it in the return duct down closer, wire it to the terminal block, and then just set the RH on the sensor.
It's the wires, not wireless.
You still have to have a wire.
It's still wire. It's still wire. Wireless is just, yeah, is not dependable enough. But I guess does anybody have a wireless thermostat?
Each of these got these little things you put all over the house now.
There's zoning wireless thermostats.
Yeah, I kind of want to.
Yeah, yeah. I don't know for RH though. That's the thing is RH sensors are so, yeah. So, and you still have the full terminal block on here as well. So if you wanted to go to the thermostat or whatever, you can still do that. But that's an option there. Rotatable collars. Most of our smaller units have the rotatable collar, so the supply can go out here. This is that smart power damper that you can use for ventilation if you wanted to with that. The newest ones that are going to be coming out the soonest, the Ultra V 155, it's our bigger unit, but our 98 pint unit is going to be going to 100 pints, and that's going to look like this, and our 120 pint unit is going to look like this as well. And the 100, the 120, and the 155, all the same size box. So all the same now.
What kind of amp draw does the 100 pull?
I'll have to pull up the back of this spec sheet to tell you yet. But amp draw on the 100, I'm going to guess is around between 6 and 7 pints. Or amps, I'm sorry. Not pints. Okay, yep.
Is that fresh air you have a reducer on it? Does that go at 8 to 6?
It looks like it goes to an oval.
Yeah, it's oval shaped.
That's an oval right there. But this is a round. Now, if you were familiar with our big units like this, we had a heat exchanger inside of our 155 and our 205. And we had the supply, the return, and the fresh air all on one side because the air would come in, go through the heat exchanger, and then come back out. And that allowed us to reach dew point faster because we pre-cooled the incoming air through that heat exchanger so we could remove more water using less energy. And that one had, and we didn't supply, but you had to use an oval around adapter on that. We're using a new patented 3-coil system on our units, bigger units, and so we pre-cool with that first coil now with the refrigeration. So the 205, that's what the 205 looks like. Again, it's an 8-inch duct. And then our new Crawlspace unit, we had the Advanced 90 out there. It had dual exhaust, and we discontinued that unit, and the industry went into an uproar. Everybody loved having a supply on each side of the unit. So we brought it back, and we got digital controls. This one has a built-in P-trap, so we don't have to raise the unit anymore to have an external P-trap on the unit, digital controls. This one, the remote sensor, so if you want to put this by the Crawlspace door, plug it in, run your ductwork down there so we can get good airflow, and then put that remote air sensor in the farthest corner of the Crawlspace, and then it'll run the dehumidifier based on where you think might maybe the most humid area of that Crawlspace is. Now this one, you would be able to use as a standalone in an attic because it now has the terminal block on it that we can wire a float switch to as well. And it has, I'm going to guess this built-in, and it has another port for a float switch. So you can put a float switch on this unit and wire it directly to the terminal block. So if this unit were to start leaking, it would automatically then shut off this unit on it. And I think, whoops. Yep, and this one has a built-in float switch as well. So you can just turn that right into there and then wire it to the unit.
These aren't out yet?
This one will probably be out late summer. This one, I'm guessing, will be out very soon because we are out of the current stock of this one. And then this one, I think, is going to be midsummer.
Where's it all made?
Madison, Wisconsin.
Where did the components made?
Yeah. Well, until we get a compressor manufacturer building factories here. So, yeah, unfortunately. We have a contractor portal. You don't have to be a contractor. You can register on there, and then we've got all kinds of trainings, webinars. If you're an HVAC contractor looking for a distributor, we have a distributor locator in there as well. So lots of, more technical information in that contractor portal. And that's it.
Awesome.
Yes.
Got a question from the internet. So when you're working on balanced ventilation, you've got the ventilating dehumidifier. Like, how do you accommodate passive house rate that balanced ventilation?
Yeah, so we call that poor man's balanced ventilation. So what we're going to try to do is connect the dehumidifier to the bath fan. And the challenge with that is we can more easily do it going one way. So the bath fan comes on, okay, we're gonna activate the fan on the dehumidifier. The challenge is having it go back the other way. The fan from the dehumidifier comes on, now we're gonna activate the bath fan. We've had projects do it. It just gets more technical, but I've got a diagram that shows how to do it. But
Is that power actuated or pressure actuated?
it would be power. Yeah, it would be power. And that's the challenge too, is making sure, I can understand how for our ventilation, our mechanical ventilation, that it is balanced. And if you're in a hot, humid climate, you don't necessarily want balance. You still want more positive, right? We want that positive pressure. But the reality is that house is not balanced, right? We got kitchen hoods, maybe, in a passive house. We've got a dryer. We've got wind outside. I know we're airtight, but we're still not a Yeti cooler. But the pressures in our house are going to typically go more negative. And so, we are more of that supply trying to make it up. But there are ways to try to achieve it. It just becomes more technical, electrical engineer kind of stuff.
Even fireplace flues don't seal when
Nope.
not in use.
No.
So even if you slightly pressurize your house.
It's really hard to put a positive pressure on a house. I mean, but our systems kind of do that supply, trying to get more to a positive pressure.
So you mentioned the kitchen exhaust ventilation. So when that kicks on, can this provide enough?
No, it cannot. No, not usually. And yeah, there's a lot of talks out there. I mean, we've had that before. Building code says I need to bring in 400 CFM of makeup air. You're not going to get that. The amount of ventilation that you can get from these units for ventilation is up to 1/3 of the total CFM of the unit. So that's a 6-inch duct. Most of the units, except for the very small one, have a 10-inch duct. And we're talking, probably rigid ducts that are short, and it's hard to get that 1/3 max, but we say up to 1/3 of the total CFM. Now, we're working with our newer units to be able to bring in more, obviously, and also to give you charts at different static pressures of how much CFM you're going to get for that ventilation.
So you're saying 1/3 of the CFM for that units, but if you need 1/3 air exchange for the house, or 0.3, I know. So will that be typically large enough to be able to provide all the ventilation you need for a house?
Well, it depends, right? Depends. I mean, it depends if we're running continuous, depends if we're running intermittent. it's gonna depend on what that house needs.
Maybe, so it's like here it says the 70 is 150 CFM, so you can get 50 CFM of ventilation.
Well, and is there a static on it? Are you looking at the static? Because we get it different. That's zero static.
Oh, right, zero, yeah.
Yep, so we get 130 CFM at 0.4. So you would take 1/3 of that.
Oh.
Yeah. Look at the other one. That's the standalone. Yeah.
You get a very small amount of fresh
You,
air.
very small amount of fresh air,
Okay.
depending on what you need, yeah. So,
Not nearly enough for 1,200 CFM kitchen hood.
no, absolutely not, no.
Fairly enough for a small.
Any other questions?
No, I was just asking for a friend.
Oh, yeah. All right.
Awesome. Thank you again, Nikki.
Sorry about that, going
You
over.
did.
Thank you, I appreciate it.
Thank you again to Nikki for being here and for Santa Fe for sponsoring this, which is super helpful.
Thanks again for Nikki for explaining this. If you enjoyed this video, we do have other dehumidification videos on our channel, and definitely go to our website. We've got articles, we've got blog posts, we've got other videos on there. Rateitgreen.com, check it out. Become a member. Membership is free. You can go in there and make comments. You can give feedback to other people that have questions about building science, but more importantly, it's a community where we're all learning together. Thanks again. See you guys next time.